Alright, I'm Christopher Owen, and this is my ConnectR code demonstration video for CS 4242, Artificial Intelligence, Section 01, Fall 2016 at Kennesaw State University. So for this code demonstration, I'll just be going from the beginning to the end, explaining how all these working parts go together as opposed to skipping around. So first, we established the two different kinds of chips using Connect 4, R being red and B being black. We then instantiate four global variables: width, how many columns wide is the board; height, how many rows high is the board; in a row, how many chips in a row, column, or horizontal are required to win; and depth, which is the depth of the min-max algorithm. We instantiate our board, C board. We create a new scanner right here. And we then have the setup game method. Setup game welcomes the player and then asks them to type in their desired dimensions of the game board: width, height, in a row. After setting the board's dimensions to the user input, then ask the user if they want to play against the computer. If the answer is no, they simply play against a friend locally. The next method, print board, is just a double for loop that simply prints every element of the board currently. We then have fill array, which simply fills the board with what we consider to be blanks, a period. Yeah, right here. The play game method is what really handles all the working parts of the game. In my game, the player is always red, so first it requests how the player moves and drops the chip in the column specified. It then switches to the second player, the AI, depending on how they answered the question about playing the computer and setup game. If they answered yes to playing the AI, then pcomp was set equal to true. If no, pcomp was set to false. Depending on their answer, this if statement determines whether or not they will reply with user input, or if we'll be using the comp move, which embodies all of the AI logic, the heuristic, the min-max, and the calculations. So lines 101 to 111 utilizes the check winner method that we defined below this play game method. And it checks for which player placed the winning move, and then outputs who the proper winner of the game is. Either red wins, black wins, or it's a draw. Drop chip, the next method, is the basis of the entire game itself. It allows you to, like its name suggests, drop a chip of either R or B color in a single column. Check winner is defined here, and it calls check winner in rows, check winner in columns, or check winner in diagonal, to check for every possible case of a win. Below this, the three cases are defined. Right here, check winner in rows, check winner in columns, and check winner in diagonals. Depending on how the user inputted in a row, the height and width of each of these cases will change to fit the needs. So basically, the rest of the code goes like this, kind of from general to specific. In terms of the methods: comp move to get comp move, to min-max, which uses one other method, copy grid, to make a copy of the current board, and then to heuristic. So let's go down and cover all of that. Right here is get comp move, which simply decides the first couple of moves for the AI initially, and then begins to use the min-max algorithm to place the rest of the second player or AI's chips. The min-max method uses the min-max algorithm to determine the best move. It's pretty straightforward, but not before consulting the heuristic, which is the beef of all of this. The heuristic evaluates the current board based on the current player's position, returns a value based on how good the current position is. Neutral is given a score of 0. 2 in a row is 10, and 3 in a row is 1,000, and 3 in a row where either side is free, at either end is free, is 2,000. It then returns the sum of these values. We then have 3 values, VDH, which represent this, stands for vertical, diagonal, horizontal. These are modifiers used in calculations for the best move. 2n and 3n are exactly what they sound like. They're multipliers for calculations as previously described. The heuristic then goes on to attempt to define the situations. Horizontal, 2 in a row. This is vertical, 2 in a row. Diagonal space, 2 in a row right here. Diagonal spaced, 3 in a row. Going top down. I think this is horizontal, 3 in a row. Diagonal spaced, 3 in a row. Open-ended, 3 in a row, and etc. So then let's scroll down here past all the calculations to get to the rest of it. So at the bottom we have copy grid, which as previously stated makes a copy of the current board to be a safe space to try out different child states or moves. We also have comp move, which sets itself to get comp move. I had to go back and change some things and ended up having to make this to get things to work properly. And finally in our main we create a board and call setup game, fill array, and play game. So in terms of problems I have with my program, let me go back to min-max to look at that. Right here. There is no GUI. I didn't have time to make one. I don't have it multi-threaded to a timer that updates the best possible answer every 8 seconds. I attempted alpha-beta pruning, as you can see from in here, but I'm not completely sure if I implemented properly in my min-max method, and I'm not 100% if the AI is playing to the best of its ability, although it seems to be capable of blocking occasionally, and it does play by itself. So now I'll do a test run of it, and of the code you see here, and we'll do a width of 10, height of 10, and put in a row at 5. And I'd like to play with the computer. So I'll just go ahead and set one down at 9, then 8, and 7. Just going to play around with it a little bit. Block it right there. It's going to keep stacking. So yeah, as you can see, the AI isn't playing at its best, but at least it can sometimes block depending on what I do. It does also make a legitimate attempt to win, just not strategically enough. Anyways, thanks for watching.